Alright, hello everyone, this is the optional video that, and just in case you wanted a little bit more examples from section 8.3. So let's continue on. We're going to look at the starting nurse salaries. According to payscale.com, the average starting salary for a nurse practitioner is $79,000. A researcher wishes to test the claim that the starting salary is less than $79,000. A random sample of 8 starting nurse practitioners is selected and their starting salaries in dollars are shown. Is there enough evidence to support the researcher's claim at A equaling 0.10? Assume the variable is normally distributed. So here's our 8 data values. In other words, these are different x values. We got to state the hypothesis and identify the claim. Our null hypothesis is that the average is 79,500, and the null hypothesis is that it's less than that, and that's actually what the claim is. So here we go. We want to find the critical value. Alpha is 0.10. We have the degree of freedom is 7 because that's 8 minus 1, and we get our critical value. Let's see exactly how you can look that up. So we have our normally distributed portion here. We have it's a left-tailed test because it's less than 79,500. We have that area is 0.10, and we look up in the t-table for that. And we figure out that the critical value that the table tells you is negative 1.415. Okay, so keeping that in mind here, now we got to find what our test value is going to do. So let's draw that picture one more time. Our t-table, we got negative 1.773. and our critical region is over here on the left. We substitute into the formula everything that we have. You can find x bar. Remember, we were given all these x's. You can find x bar by adding them all up and then dividing by 8, just like normal. And then subtract the mean that is for the claim, our standard deviation for our sample, and that's why we're doing the t-test, remember, because we don't know what the standard deviation is for the population, and then divide by the square root of our sample size. And when you do that, you get negative 1.773. Oh, okay, so I just figured out that I wrote down the wrong number. So the number here from our table, if you remember, is that negative 1.415. Let me fix that. Sorry about that confusion. And then we got to figure out where negative 1.773 is. And actually that is right here. All right. So it is in the critical region. So that means we want to reject the null hypothesis. So we have it in here, and okay, another typo. We want to reject the null hypothesis. Since this negative 1.773 falls into the critical region. Okay, so let's just remember what the claim is. All right, our claim was the alternate hypothesis. And that is what we're accepting to be true, because we said that the null hypothesis, since it was out in the critical region, we're going to reject the null hypothesis. So that's our claim, and that's what this sentence is saying. There's enough evidence to support the claim that the average starting salary for nurse practitioners is less than $79,500. All right, one more example if you choose to pay attention. All right, here we go. Next one. Joggers oxygen uptake. I actually did this test today with the exercise science majors. So let's see. I don't know what my values were. They told me, but I don't have the paper with me, so we'll just have to go with this example. So it says that a physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. A sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6 milliliters per kilogram. If the average of all adults is 36.7, is there enough evidence to support the physician's claim at alpha equals 0.05? All right, null hypothesis, it's just the average, 36.7 for the whole population, and they want to know if it's greater than that, and that's the claim. All right, so here we go. Let's try. We got to draw our bell curve. We're doing the t-test because sigma is unknown. Okay, it's a right-tailed test. All right, and then we have to figure out what the t-value is. So there we go, we compute it. Oh, yeah, before we do that, let's figure out what the test is. So we know that our area is 0.05. We can figure out what that is. We look up in the table, the t-table. 0.05 on a one-tailed test, and then the degrees of freedom. So degree of freedom, how many people did they ask? 15 joggers, so that's 15 minus 1, so we have our degree of freedom is 14. When you look that up, all right, I'm having trouble looking that up. Give me 1 second. So we look up our area. We want 95. Our degree of freedom is 14. So we get the value 2.145. Okay, when we find the t-test, all right, we substitute in all our values. So I'm sure you guys were looking at it while I was running to get my table. And we see that our value is 2.517. So that's over here in the critical region. All right, so that means that we're going to reject the null hypothesis. This slide's just showing you if you wanted to do the p-value, if you wanted to figure that out. Okay, so we want to reject the null hypothesis. And our reasoning was a little bit different because we did it a different way. But we reject the null hypothesis. If you remember, the alternate hypothesis was the claim. So our summarizing results say that there's enough evidence to support the claim that the jogger's maximum volume oxygen uptake is greater than 36.7. So there we go. If you run a